software developer here in San Diego, and I am fascinated by the applications of computer science in the finance industry, specifically in trading. And you should all be too, because it's a very lucrative career path. In 2016, there was a 34-year-old trader who made $100 million in just 6 months, on his own time, legally. So quantitative finance isn't for everybody. It's extremely mathematically intensive. So if you're here and you have a mathematical background or a physics background, then you're already ahead of the pack. I've given a lightning talk here before called Python for Options Trading, and today I'm going to give one on a related topic, derivative analytics. So the concepts are going to overlap because an option is a type of a derivative. So, what is a derivative? In finance, now when you saw derivative, you probably thought of like a calculus derivative. In finance, a derivative, it's a contract that derives its value from the performance of an underlying entity. And that entity can be an option, a future, a forward, a swap, a warrant. And derivatives are used for speculating and hedging. So when you're speculating, you're trying to make money from changing prices and the underlying asset. And you can make $300 million in 1 year from doing that. Like, I'm serious. There was a team of derivatives traders at the CD Group that did that in 2016. And when you're hedging, you're trying to insure against price movements. So I'm going to be focusing on DX analytics. So DX is short for derivative analytics, and that's a Python library. It's open source, it's free. And it allows for the modeling of complex derivative instruments and portfolios. It provides a lot of useful classes for financial analytics. For example, there's a class that does mean variance portfolio analysis. There's a class to model interest rate swaps. It was developed by Dr. Ian Hilpich, which is the author of Python for Finance from O'Reilly Media, and the author of Derivative Analytics with Python from Wiley Publishing. So if you're planning on pursuing derivative analytics any further, you've got to read these 2 books. So there are 3 main simulation classes in this DX library where you can model relevant risk factors. And they are geometric Brownian motion, jump diffusion, and square root diffusion. And I'm kind of going to go through each of these 3 and explain briefly what they are. So first, geometric Brownian motion, a very important concept in finance. It's a continuous time stochastic process that does a log normal distribution. It's used to model options prices in the Black-Scholes model. So I went over stochastics in the Black-Scholes model in my last talk, but in case you missed it, stochastics, they're unpredictable events that can be caused by a random variable. And the Black-Scholes model is it's one of the most important equations in all of finance. It's a model that does price variation over time. So geometric Brownian motion is abbreviated GBM. It's the most widely used model of options price behavior. And when you use the method to plot it, that's what it looks like. So jump diffusion. So the jump diffusion model is different because it incorporates these small day-to-day diffusion movements together with these large jumps. And these jumps, they allow for more realistic price scenarios in the market. And then there's square root diffusion. It models mean reverting quantities like interest rates. And what mean reverting means it's just the assumption that the price is going to move to the average price over time. So this dashed line represents the long-term mean. And the process on the graph, it stays positive, which is a very desirable process for these quantities, or a desirable characteristic for these quantities. So calibration is also very important in financial modeling. So calibration is a mathematical model in finance where you determine all these risk-neutral parameters that govern the evolution of a price process. So the most widely used function for calibration is the mean squared error function, and there's a function for that in Python, mean squared error, and that's fairly easy to implement. So I mentioned at the beginning of my talk that derivatives are used for hedging. So dynamic delta hedging, it's a derivative trading strategy where you're trying to reduce or eliminate or hedge the risk that's caused by price changes in the underlying asset. So a derivatives delta, that's dP over ds. It's the relation between changes in the derivatives price and the changes of the price of the underlying asset. So if the underlying asset's price changes, then the derivatives price is going to have to change. It's going to have to change as well, and that's what that delta represents. So when you're doing delta hedging, you're going to have to make another trade that neutralizes that delta. So that's why we have dP minus delta ds equals 0. So that neutralizes the delta. So I guess a real life example of that, let's say you have an option with a 0.25 delta, then you're going to have to own 25% of the amount of the asset that's covered by the option to protect yourself from losing money. So the DX library has a method that's called BSM hedge run, so BSM Black-Scholes model hedge run and plot hedge path. Yeah, so I know I just threw a lot of information at you and it might seem pretty overwhelming. I mean, I know that I'm talking to an audience with a development background and not a finance background. The thing is though, you really need to understand the mathematical and the finance concepts to be able to program these trading systems. Once you understand these high level, like these theoretical, mathematical, and financial concepts, the DX APIs are very simple to incorporate. The documentation, I believe it's derivativeanalytics.com. The documentation is very good. So my contact information is here. If you want me to slow this down for you, start from the very beginning, maybe meet up at the Saturday study group and kind of talk about this in more detail. If you want me to send you the slides or point you in the direction of free learning materials, I'm really happy to do that. Again, my contact information is up here, or you can just message me on Meetup. So yeah, that's pretty much it.